I'm talking about publishing scientific metadata. This is the EOSC what I was talking about, and this is the governance structure of the EOSC project. So on the top level, there is a European policy, which is governed by the European Commission. So there is some legislation that covers what the EOSC project is doing, opens up space for EOSC association, which is organization on European level that is responsible for the implementation of the EU policy. And because this is the federated project, we have the national nodes on the country level, and those national nodes are responsible for implementation on the national level. They are creating national infrastructures and this kind of stuff. And then it is federated back to the European level, where it shall be somehow interconnected. The project is still running. It shall be running until the end of 2027. But after that, I think that there will be some upcoming projects that will follow up what was created here. So, but until the end of 27, there should be the infrastructure implemented and ready for use. So how is it implemented in the Czech Republic? Basically, this is how the infrastructure should look like. There has been some calls in open science call projects in various calls. One of the first calls was called OS1, then we had OS2, and now we have OS3, which means OS is for open science. And there are some sources where the infrastructure components were created. So there is the IPS cards and IPS EOSC CZ. The first part of the project is to somehow set up the environment for persistent identifiers on the level of EOSC and on the level of Czech scientific community. So on the top level, we can see the central discovery portal. This should be some web page probably that is like the landing page for everything else. Then there is the National Repository Catalog. National Repository Catalog is a tool that allows discovering of all repositories that were created during the project. And also there is a National Metadata Directory, which shall allow users to go through all the metadata, find some data using the metadata and so on. And then there is the NRP, which stands for National Repository Platform. And in this National Repository Platform, there is a space, like the infrastructural space, for creation of domain-specific data repositories, thematic and also other repositories. And then there are some centralized repositories. Basically, there I know about catalogue repository. This means that if your organization does not have thematic or other repository which is set up for your data, you can upload your data into the catalogue repository. And that's basically all. This infrastructure, this is something I don't really understand much about it, because this is everything done in on some servers on testnet and this kind of stuff. What is important for me right now is that all the data that are in those repositories shall be findable through the National Metadata Directory. There is also on the policy level, there is also said that all the data which are published shall be published in accordance to the FAIR principles. The first principles are findability, accessibility, interoperability, and reuse. And here is written what are the basics of the FAIR principles. So for the F, for the findability, states that metadata should be assigned with globally unique persistent identifier that should be described with rich metadata. For the accessibility, there is important thing that it is retrievable using some open, free, universal implementable protocol, and the metadata are accessible even if the data are no longer available. For the I, for the interoperability, important thing is that metadata and data should include qualified references to other resources. And for use, we basically focus on the fact that metadata shall meet domain relevant community standards. This basically means that there shall be some basic metadata profile that will cover all scientific metadata, everything they have in common. But on the other hand, it shall be possible for domain-specific repositories to extend those metadata to meet the domain-relevant community standards. And this is basically the need of going FAIR here means that all the data shall be covered with metadata, and those metadata shall be implemented in some metadata catalog that will be open and accessible for everyone. So in the EOSC project, in the Czech note of EOSC project, there is a bunch of working groups. There are 4 cross-domain working groups focusing on infrastructure, metadata, and so on. And then there are 8 basic domain-specific groups that are focused on what is the common understanding, what shall be implemented, and what is specific for the given domain. In the domain we have, I don't know, we have there material technologies, we have physics, we have artificial intelligence, then there is nature and environment, and so on. And the metadata working group shall provide support for the national metadata directory. Basically, this was how it was created. The whole infrastructure, including all repositories, is driven by CESNET, and CESNET has developed its own Invenio tool. Invenio is a data repository, and they had a brilliant idea that they would use this data repository also as a metadata catalog, which in my opinion is not really a good idea, but they thought it was brilliant. And this working group last summer, they had a goal to specify what metadata profile will be used for this core metadata directory. This national metadata directory, as I said before, should collect all the metadata that are describing all the scientific data that are published almost in any repository. So this should be something which is really specific for everything. And what do you think that metadata working group has done? They created a questionnaire, and in that questionnaire, they summed up like 5 or 6 metadata profiles, and then they asked the members of the working group if they have any experience with any of those metadata profiles, and they let them choose which one to use as the core metadata profile. So in the end, it ended like it had to end, that they picked up the simplest metadata profile there is used because they know it and then they know how to use it. On the other hand, this metadata profile is not really rich, and it does not really cover the attributes that shall be used for searching and discovering of the data. So there was an idea to create a new metadata profile that would be specific for scientific metadata in the EOSC project, and that shall reuse existing vocabularies that were ever created to cover the topics that are needed to be covered inside the project. So for the basic description of the dataset resources, there was usage. We have chosen Dublin Core Metadata Initiative because it is a top level vocabulary that covers the description of datasets, and moreover, it is reused in most of in a lot of other metadata profiles just to cover the basic needs. Then we needed, this was also part of the project, that all the data shall be provided with some persistent identifier. And in this open science world, the persistent identifier, the most used persistent identifier is DOI. And the DOI is attached to the resource based on the data site metadata record. So to get the DOIs, it is important to be in line with datasite metadata profile, at least in semantic way, with the mandatory attributes. To access the findability, which is important for fair principles, we decided to use DCAT, which was made for data catalogs. So basically what we are trying to create here is metadata catalog. So DCAT is a good option to use. And for interoperability and extensibility, we decided to use some stuff from the RDF and RDFS vocabularies. So basically the profile will be in the RDF. The three basic vocabularies which were reused to create this metadata profile, which is called core metadata model. The first C stands for Czech core metadata model. This is basically a merge of DCAT, Dublin Core, and DataSite. This is how the metadata was created in the beginning. The working group had a meeting, and on that meeting they were trying to find out what are the basic metadata they need to cover from the needs of DataSite to get DOI. Also, what is important, what every metadata record for each scientific dataset should include. So basically, we have some information about the data set, about the metadata record itself. We are using some subjects in the meaning of keywords, distributions, how to get to the data itself, which is taken from DCAT, obviously, and also some references to location, funding, terms of use, and also to some agents in any relation to the data set. In the beginning, this is how the needs were created, but then in the beginning of the year 2025, there was a need to cover it in a documented way and to cover the specification, and part of the EOSC project is also Jakub Klimek and his tool, DataSpecker. So we decided to use DataSpecker to create the model. So basically, from this, we went to this. We can also create the application profile of the metadata model here. And the upsides are that we can also export the RDF representation of the metadata profile here. We can do we can use the structure editor to define the structure, which will create also the XML or XSD representation of the metadata profile. And also we have the specification which was generated automatically by the respect tool. You can do quite a lot of things in the conceptual editor. You can use the profiles of existing concepts, set up the domains, ranges, cardinalities, narrow definitions, add some usage note on how to use this this concept in the context of this metadata profile and so on. This is how the specification looks like, basically. And this is how you can create the structured, in the structure editor, you can define the structure, which will be then exported, automatically transformed into the XSD specification of the metadata profile. So in the end, what we got the metadata profile created, which is provided with RDF file, respect specification, and we also have the structured model for the XSD. Where the problem started is that the national metadata directory is created in Invenio, which is basically running over some SQL database. So they got the XML metadata, then they do some transformation from XML metadata to YAML file, which is configuration file for the Invenio tables, and then it is somehow transformed to the SQL table in Invenio. And now, what are the problems? Basically, the NMA serves as a repository for all metadata, and no one is creating the metadata manually and putting it into the NMA. Usually, the domain groups or universities or some other scientific organizations shall have their own data repository, and this data repository should support some kind of metadata. Basically, if the repositories are created, newly created for the project, then they may be able to set up the metadata profile they will be using in a way that it is interoperable with this XML and that it will be put into the NMA. But if it is not, then there has to be created some mapping that will transform the metadata from the original resource to this XML metadata prescription that is used in NMA. This is, I think, this is quite. This may happen quite often because in some domains you have some very domain-specific metadata profiles which are used in the worldwide community, and you are used to it, you are using it every day, and you don't want to change it. So you just need to set up some transformation. Preferably, I think it would be nice if this would be some, I don't know, web service maybe, which would transform the data into the NMA. And this is how the NMA will be filled, probably. So the problems is mapping the existing metadata to the core model. Second problem is that creating domain-specific extension to the core model may be also problematic. This stands for the case that you are creating the new repository, which is domain-specific, and you can create an extension of this core model. So you don't have any metadata profile set up yet. So you are creating a new one. You want to come up from the core metadata model, but you want to set up some extensions which are domain-specific. This is really easily done using the RDF and using the DCAT, because you can just create another application profile, reuse what you want from the core metadata profile, and you can add new attributes, new classes. You can add anything you want. The problem starts when you are transforming it to XSD or XML, because in that case the XSDs you cannot just reuse everything what was created in core metadata model, because using the data spectre tool you are creating the new profile of everything. That means that even the stuff you reused from the core metadata model is now a new. is now just profiled in your new profile, and that means that it will have different IDs, different IRIs, and then that leads that you cannot easily recognize what is the original stuff and what is reused. Another problem is that you are flattening the metadata to get it into the Invenio. For me, this is the big issue because as the data set or metadata catalog was basically chosen a tool which shall serve as a data repository. And in that case, it was not created to be used as a metadata catalog. So I think that one of the solutions may be to run some pivot or something like that that will serve as the metadata catalog that will provide the RDF metadata in DCAT or in the core metadata model without flattening it into XML and so on. And also the problem that is connected to usage of Invenio is that the metadata, it is not a metadata catalog. So discovering metadata on the web is not as easy as using some catalog services and so on. I was also looking at some tools that may help us with the second and third problem. It is a tool which is called 3M, but I think that it is also possible to use RML or something like that. And this is creating the functional mapping between XML or some other structured files, basically in tabular files, to the RDF. So you just, if you have the repository which contains millions of records, for example, and all of them have the same structure, they're using some, I don't know, CSV or XML, JSON, and anything, that if you create the functional mapping to the core metadata model in RDF, you can transform the data into the structure you want, and you create the mapping file, which will take, I think, a lot of work. But after that, you can use it to transform all of your metadata, and you can do it on the fly using some data web service, probably. So we are still working on the solutions, and this was some overview of how the metadata in the scientific communities shall be published. That's all from my side. Thank you for your attention. Yeah, this is also, yeah, I added this one slide. I forgot about that. This one slide is about how does it actually look now in the NMA. So this is the front end of Invenio. How does it shows the metadata? And as you can see, this is something as is probably expected that this shows the metadata of the data which are not meant to be published as a metadata catalog as a DCAT. It is quite flat, and also it provides some distributions of the data. But if you look at it, the distribution is something which is zipped, and also some markdown README file. So I'm not really sure that this is the distribution of the data set itself actually or not. Here are some references, and that's all. So do you have any comments or questions?
Okay, thank you for the presentation. I have one question regarding this NMA. So if you have your repository and you have your metadata describing data, they are transferred to NMA, right? The metadata
Yes.
transferred to NMA. But you were talking about the domain-specific extensions. So those domain-specific extensions should be as well migrated to NMA or not?
Yes, it shall be. It is what they want to have it in NMA. the developers of the NMA, they want to have everything what is from the core metadata model. They want to have it structured. And basically in the database, they want to store everything. That means that also the domain-specific extensions. And in the full text search, you can also search by the attributes which come from the extensions. But it will not be visualized in the forms, because the inventor does not know what extensions are there and what does they mean. So what do they mean? So it basically shows only the content of the core model.
So it will be searchable but not viewable.
Basically, yes.
Okay.
But the goal is that one part of the core model is linked to the original metadata record. So basically, if you have your domain-specific metadata somewhere in your domain-specific data catalog, you put your transformed metadata to the NMA. If you find this record in the NMA, you can link to the original repository where all the metadata will be listed.
Okay. All right. Okay. Thank you.
Okay, so no more discussion. So thank you for your attention, and I think that we will see each other next week.
Question by me.
Okay, so ask.
Sorry, I kind of got lost, but is this just, if you can repeat, if this is specifically for vocabularies or for any kind of data?
This is for any kind of data.
Any kind of data, okay.
Any kind of scientific data is.
Okay, yeah, scientific data. Yeah, sorry.
Yeah.
Okay.
There is also they have some plans and some dreams that this could be somehow connected to Huawei system, and that everything which is exported to Huawei could be exported from NMA probably.
I remember we were speaking with Ricardo regarding some European project. Was it Horizon? I'm not sure right now, but it was also kind of regarding sharing some sort. Sorry?
Cost action project.
Cost action. But wasn't it trying to make a Horizon at the end? Because the cost action was just a community building.
Yes.
But I felt that this is a similar thing. It's just more specific, not for any scientific data, but just for, I guess, material degradation or something like that.
Yes, but they want to publish it into. It's called EOSC, European Cloud for Heritage and Open Science.
Sure.
Heritage Open Science. Yes, Heritage Open Science. EOSC, yeah.
But is it possible that this is somehow stems from this initiative, because this is a European initiative, right, Michal?
No. Yes, so it would be nice to know how much it is connected to the
details.
You know anything about this European Cloud of Heritage Open Science?
No, I'm just looking at it, and cultural heritage. Basically, if I look at it, I'm looking at this EOSC, and I think this is not for all open science scientific data. This is just focused on the cultural heritage data.
Yeah, but does it fit to you were explaining this European activity. So does it fit as a part of?
I think it should have, but I don't know if it is somehow connected, because this is the first time I hear about this EOS.
Yeah.
Yeah, the output of the project should be there inside of this, but it is still forming this cloud, this European cloud for heritage. It's not working, I believe, yet. If I understood correctly. Yeah.
I also have some some issues with how the EOS project is implemented, because the general goal is to just to reuse what exists and interconnect it. By the testnet here is creating the whole new infrastructure for everything, and they are trying to centralize it a little bit. This is something I'm not really agreeing with, but it's sure not my call.
How about from our side? Like, we are talking about publishing vocabularies and stuff like that. I don't know. Maybe from aviation side, they would have some public data sets. Obviously not like from the airport, but maybe something that should be public from the airport. So can we somehow, should we somehow get engaged into this, or?
About that, I'm not really sure. I think that basically this should be solved on the level of universities probably, and if we have something like DSpace or something like that. So this is basically what should be integrated into these infrastructures. I don't really think that this is something that should be integrated from the level of our research group. We are too low for that, I think.
Mm-hmm. And how
there is some institutional repository for collecting the research data, which I'm not really sure if there is something like that. I know that there is something like that at CTU, but I don't really know if there are some obligations, how to upload the data there, what to do with it, and so on. But as my experience, I think it should be interesting, definitely. But my experience with what data are uploaded there, it's basically I was talking a lot with people from archaeology, which have some field research, and they are collecting samples and this kind of stuff. So this is something that is described in those data repositories. And also I'm working with bioimaging, which are basically biologists that are doing a lot of microscopy images, and those images are the data outputs, or also with the material technology. So they have a lot of tools, some big machines that are measuring something all the time, and they are doing some protocols, some research laboratory notebooks, and those are the data they are publishing to those repositories. And basically they do it because they need, when they are publishing some papers or some studies, they need to interconnect it to the data from which it is originated. So those are the data that originates the papers, or this kind of stuff.
Mm-hmm. So actually, there are no vocabularies there, things like that, ontologies.
There may be, but not a lot of people are using these ontologies.
Yeah.
But we can definitely provide it. It's not a problem, because what is data set inside this core metadata model? The definition is taken from DCAT AP, and DCAT AP says the definition is really wide. So you can get in I don't know, the field measurement of some surveying, and you can also use it as for ontologies. So that fits.
Okay. Thanks.
It should be. This was intention, because the core metadata model should cover all scientific data, and the extent of what scientific data maybe is really wide.
Is it somehow trying to solve not public data as well, or just partially public data or something like that?
Yeah. It is. But the thing is, it is open science, but open science, it's not the same like open governance, because open governance means that everything is open. Open science means that you may have really good reasons why not to publish the data. There is also the working group which is focused on sensitive data. And in the core model for metadata, I also solved it somehow that in the terms of use, you may set that your data are not publicly available, or there is also some embargo. This is something which is quite common in the scientific community, that the data are embargoed until the paper is published, for example.
Okay. So there is a technical support for that.
Oh yeah, it is.
Okay.